for joining me once again in another interesting tutorial of chemistry. This is your tutor, the science guru, Mr. Moviana. In today's lesson, we are going to start looking at metals. What is a metal? So, a metal, by definition, a metal is an element that ionizes by the loss of electrons. Let me just repeat that again. A metal is an element that ionizes by the loss of electron, or an atom that loses electrons. So, on the periodic table, any atom that loses electrons, for them to become stable, they can be categorized to be metals. Now, I want you to take note of this. Metals, they have a range of a valency from 1 to 3. So metals, they've got a range of valency from 1 to 3. So let's just put that in writing. So we have that now. So we are looking at characteristics or properties of metals. Now, guys, I want you to take note of this. These metals, they've got special properties. One of them is this. Metals are lustrous. What does it mean? Meaning that a metal can be shined. Okay? 2. Metals are sonorous. What does it mean? Meaning that whenever you hit a metal, it will produce sound. Also, metals are malleable, meaning that they can be molded into different forms without breaking. Then, metals are good conductors of electricity. Okay? Another thing on the properties of metals, I want you to take note of this. Metals have a high melting and boiling point. Okay? So, go through this. Metals are sonorous, they produce sound. Metals are lustrous, can be shined. Metals are malleable, can be folded or molded into different forms without breaking. Metals are good conductors of electricity. Also, metals, they've got a high boiling point and melting point. Why do metals have a high boiling point and melting point? It's simple. It's because of their strong electrostatic forces of attraction. Okay? Metals are made up of strong electrostatic forces of attraction. So, the next part that we're going to look at, the reactivity series of metals. What does it mean, the reactive series of metals? So, the reactivity series of metals, guys, listen to this. The reactivity series of metals, this is just the arrangement of metals in the order of their reactiveness. This can be defined as the arrangement of metals in order of their reactiveness. Now, how does the reactivity series of metals look like? So you've got 1, you've got K, okay, so this is the reactivity series of metals. So these ones on top, they're the most reactive ones. And these ones are less reactive. So we've got a song. Kaunda now can make Kaunda now can make all Zambians free, provided, okay, I missed one thing, provided he could. So, metals, take note of this. These metals that are more reactive, these they these metals that are more reactive, these metals they exist in their native form. Okay, meaning that they are so meaning that they don't come as combined. Okay, so hence these metals they are mostly very reactive. So when extracting these metals you can only extract them by electrolysis. Okay, carbon carbon is both native sometimes and combined. Then carbon, you can extract it using reduction. But now, this carbon is only used as a reference point, no need. Hydrogen is only again used as a reference point, no need. Then, we've got these ones now. We've got zinc, iron. These, you can extract them using reduction with a reducing agent. Okay? These they come in a combined state. In a combined state, you have to understand these terms. Native, single. Combined, it's made up of two or more elements. Okay? So now these ones, zinc, iron, you can extract them using reduction with a reducing agent. Mostly, the reducing agent used is carbon monoxide, just like that. So the next part that we're going to look at is the extraction of iron. Yeah, so we are looking at extraction of iron. So iron is extracted from the ore. What is an ore? An ore is a natural occurring mineral where a metal is extracted from. I want you to get that. It's a natural occurring mineral where a metal is extracted from. Now, extraction of iron. Now, I want you to take note of this. Take note of the ores where iron can be extracted from. We've got hematite, we've got magnetite. Now, between hematite and magnetite, we use this one, hematite, to extract iron because in hematite you've got more iron compared to magnetite. Yeah, so what are the raw materials needed to extract it? You need coke. Coke, it is carbon. Okay, you need iron ore, which is iron 2 oxide 3, which is hematite. You need limestone. Limestone, it is calcium carbonate. You need hot air, which is just oxygen. Okay? Then, now, I want you to take note of this. A mixture of limestone, carbon, and iron ore, they form what we call a charge. Okay? They form what we call a charge. Now, here are the steps. Here are the steps for the extraction of iron. Here are the steps. So, the steps are these. Here are the steps, guys. Step 1, the coke is roasted in air to produce carbon dioxide. You need to be careful with these equations. So coke solid, will be roasted in air, 2 gas, to produce what? To produce carbon dioxide, 2 gas. You get it? Yeah. Now, step 2, more, more coke will react with carbon dioxide, carbon dioxide to form the desired desired reducing agent. Okay, more coke will react with what? Carbon dioxide to form the desired reducing agent, which is carbon monoxide. This is carbon monoxide. Okay, so when you react coke solid plus carbon dioxide, you are forming carbon. You get it? You are forming carbon monoxide, which is your desired reducing agent. Just like that. Just like that. Step 3 now. Step 3. Step 3. It is this. The ion, the ion, the ion O is reduced to ion by the reducing agent. So this is step 3, guys, very important. So ion to solid. What is the reducing agent? Carbon monoxide gas. You are forming ion, okay? Ion solid plus carbon dioxide gas. You get it? You have reduced what? You have reduced this ion. You have separated it from its ore. So now that you have formed this guys is not pure. Okay? This ion is not pure. How do you purify it? Step 4. Step 4. Step 4. Limestone. Limestone. Limestone is decomposed under heat. So you have to decompose limestone. So it's heated. So limestone, this is your limestone. Calcium carbonate. 3. Decompose it. You're going to form calcium oxide plus carbon dioxide. You get it? This is solid. This is solid. This is a gas. Something like this. Now, what's the whole point of decomposing? Check, guys. You want to purify this ion. This ion contains sand. Therefore, then step number 5, you're going to react the impurities in ion, which is sand or silicate, with this calcium oxide. Okay? We say step 4. So we have that step 4. We are saying calcium oxide react with sand to form calcium silicate. So calcium oxide will react with sand. Sand, the chemical name for sand is, guys, it's calcium silicate. So once they react, you're going to form calcium silicate. Now, I want you to take note of this. Now the ion is pure. Now, this thing called the extraction of ion is done in what we call the blast furnace. So let's take a look of how the blast furnace looks like. Okay, let's take a look. How does it look like? How does it look like? How does it look like? We say the blast furnace. So, this was built to make the process of extraction of iron to be made easy. So, the blast furnace, guys, will look like this. So, on top here, you're going to form a charge. You know what a charge is made up of? Yeah, and these are what we call the tullers. So these tullers, they're used to hot air enters and hot air comes out. Now sometimes in the exam they'll ask you what is the purpose of the hot air. So it's to maintain a maximum temperature inside this furnace. Okay? Then as we are going, since two things are going to be formed. You're inside, two things are going to be formed after I've done everything. Two things are going to be formed. A slag and molten iron. So now, iron is less denser. Slag is more denser. So you're going to notice that the iron is more denser. It will go down. A slag is less dense. It will come out of this side. And molten iron will come out of this side. Check the difference. This is settled in, coming out this side. This is just above, coming out this side. Now this slag is mostly used in construction of roads. Construction of what? Of roads. And you've got the uses of iron there. So iron can be used for so many purposes. One of them, it is used to prevent rusting. Thank you for watching. This has been your tutor, the Science Guru. Take care.